In this video, let us learn about the different kinds of operators in Python. Now, I told you how to assign values to variables. A is equal to 5, B is equal to 10 plus 2 and all that. Let me also tell you one thing. When you want to assign the values in a single statement, that is also possible. You can assign values like this. 5 comma 6 plus 2 comma 10, like this. Now what happens? The first value is assigned to the first variable. This value is assigned to B and 10 is assigned to C. Only thing is, when there is a mix match of numbers, this becomes wrong. Why? Because there are only two variables this side and three values on the other side. This expression becomes wrong. This is correct. And when you want to assign the same value to more than one variable, say A, B, C as 5, you should not do like this. You should say A is equal to B is equal to 5. This is correct. This is how the same value can be assigned to different variables. Right? Now let us get into operators. What are the different kinds of operators that are supported by Python? The first kind of operators are arithmetic operators. Actually, operators can be broadly classified as unary operators and binary operators. Unary operators, we don't have much of them. You just have plus and minus. You would have used this minus 5 plus 2 to indicate the symbol, negative symbol or positive symbol for a number. Those operators which operate with a single operand is called a unary operator. Unary means single. There is only one variable or a value which is needed for the operator. These two operators are called unary operators. The remaining are all binary operators. Right? What are arithmetic operators? The arithmetic operators are plus, minus, star, slash, double slash, modulus, double star. I'll tell you what is all this. Plus stands for addition, minus stands for subtraction, star symbol stands for multiplication, slash stands for division, slash stands for integer division, or you call it as floor division. This gives the remainder of division. This is exponentiation. Now let us check how all this work. Okay, let us work this in Python itself. So in case you're going to work all this in Python, you can download Python software from www.python.org, and you have two modes of working in Python. This is called as the shell mode or the command mode. One command can be executed at a time. You cannot type a big program or a set of statements and do it together in the shell mode. Actually, whatever is displayed here is the shell mode. In case you wish to save a program and execute it together, then you have to go to the script mode. How do you go to the script mode? Go to file, new file, and you can type all the commands one by one, the entire program, save it with a name and execute it together. But this is the shell mode, which can be used to get a simple easy commands can be executed and get the answer immediately. So let us have a demo of the operators, the arithmetic operators. So what is the purpose of a plus operator? You get the addition value of two or more than two variables, and subtraction, minus, star stands for multiplication, slash stands for division. Now look at this, 90 divided by 20, the answer is 4.5. Then I showed you an operator called slash slash double slash. This is called floor division. What is the purpose of floor division? It will truncate the decimal place. It will simply ignore the remainder. What is the rounded off quotient? That alone will be given as the answer. See, 4. Then when you say 90 modulus 20, this will ignore the quotient and the remainder is given as the answer. 10 is the answer. How does this operator work? See, when you have 90 divided by 20, it is divided 4 times and the remainder is 10. So when you do floor division here, the quotient is given as the answer. That's why you get 4. When you do 90, floor division 20, the quotient is given here. But when you give 90 modulus 20, the remainder alone is returned as the answer. So we have lot of uses for these two operators. We will use these two operators in lot of programs, right? You will get to know soon about this double slash and percentage symbol. And this double star stands for the exponent symbol. So when you work with expressions like x square, y cube and all that, you will write x double star 2, y double star 3. Of course, there's nothing wrong when you say y into y into y. This is also right. But when you use the exponent operator specifically, then you have to use double star. So these are the arithmetic operators. Next comes the assignment operator, which we already learned. What is the assignment operator? Equal to. What is the purpose of equal to? X is equal to 5. A is equal to 10 plus 2 minus 1. So you are computing some value and assigning it to the variable in the left hand side. That's why equal to is called as an assignment operator. Then you have augmented assignment operators. What are augmented assignment operators? Whatever arithmetic operators we learned just now, plus equal to, minus equal to, star equal to, slash equal to, double slash equal to, double star equal to, percentage equal to, modulus. You call this as modulus. You don't refer it to as percentage symbol. Modulus equal to. What is the purpose of all these augmented assignment operators? Suppose you have a variable a as 20. When you say a plus equal to 5, the value 5 is added to the value in a and substituted again inside a. Suppose you have a equal to 10, a minus equal to 7. What does it mean? Whatever is the existing value of a, subtract 7 from that and assign the answer to back to a itself. So this 10 disappears and a now has a value 3. So, whatever arithmetic operation you have, that is first performed with the existing value, and the new value or the result is again substituted to the same variable. That is the purpose of augmented assignment operator. Instead of using another variable, say you have a is equal to 5, we say b is equal to a plus 5. So what happens? A value remains as 5. That 5 is added with another 5 and the new value is stored inside b. But when we say a plus equal to 5, 5 plus 5, 10 is put back inside the value of a. This is the use of augmented assignment operator. Actually, this is a shortcut for the expression a is equal to a plus 5. What happens here? You add 5 to the value of a and assign the new value to a itself. Instead of giving a big expression like this, you use the shortcut operator plus equal to. So when you are asked to write, what is the other way of writing the expression? B plus equal to 5, then you can write b is equal to b plus 5. Or when you are given a question like this, x is equal to x power 2. Write a shortcut way of doing this expression. Then you can write x double star equal to 2. This is how you use augmented assignment operator. Then comes relational operators. What are relational operators? There are six relational operators: less than or equal to, greater than or equal to operator. When you say equal to, you have to use two equal to symbols. Then not equal to is the exclamatory followed by equal to. Remember, when you use less than equal to, greater than equal to, double equal to, not equal to, don't leave any space in between. It has to be continuous. When you write like this, it is wrong. You have to write without a space. Less than or equal to, greater than or equal to, equal to. Now, what is the difference between this equal to and this equal to? I already told you this equal to is called as an assignment operator. When you use a single equal to, you just assign a value to a variable. But when you say x double equal to 5, you are not giving value of the 5 to variable x. Instead, you are checking whether the x value is equal to 5. You are checking whether both are equal. The LHS and the RHS are equal or not. If you want to check that, you have to use double equal to. So single equal to and double equal to, you have to know the difference. This is a very important question generally asked in exams. What is the difference between this and this? Equal to is an assignment operator which is used to assign a value to the variable in the left hand side. Double equal to is a relational operator which is used to check if the left hand side and the right hand side values are equal. And with the output of a relational operator, when you compare two variables, if you want to check A is less than B, C is greater than or equal to B. If you do operations like this, the result will be a Boolean value, true or false. When you use a relational operator, Python compares these two values and says if it is true or false. That is the use of relational operator. The output of all the relational operators are always true or false. It will check the expression and tell you if the expression is true or if the expression is false. But the output of an arithmetic operator is a number, because you do addition, subtraction, multiplication, exponentiation, something. So you get a number as the answer. But in relational operator, you get the Boolean value as an answer, right? Next, you have an operator called identity operator. Identity operators are is and is not, is space not. What is the purpose of this is and is not? So I already told you there is a method called id. Say you create a variable 10. When you type id of A, you will know the unique memory address location where this 10 is stored. Now this is operator will fetch if two different variables are saved in the same location or not. Now, Python has a beautiful way of assigning values to variables. Whenever you say A is equal to 10, B is equal to 10, C is equal to 10, Python will have a single 10 inside the memory and tag all the names to the same memory location. So A, B, C all refer to the value 10. All have the value 10. Now when the value of C is changed to 15, it is removed from this place. A and B alone will point to 10. So how to find if they share a location or if they are saved in two different places? In that case, you use the is operator. When you say A is B, this will give you the answer true if variable A and variable B both are stored in the same memory location. Suppose they are stored in different locations, A is B will give you the answer false. Right? Now let us check how this operator works. Now I assign A as 10, B as 10. Now I check A is B. Now it says true. Why? Let us check that. We'll see what is the ID of A. See, you have a very big number. This is the address of the memory location where variable A is stored. Now I'll check ID of B. See, both are pointing to the same memory location, right? You have both A and B saved inside the same memory location. That's why A is B returns true. Now, if you have different values, A is 19 and B is 20, now you check if A is B, it says false. Now, let us check what is the ID of A and what is the ID of B. Because the values are different. 19 is saved in some other place, 20 is saved in some other memory location. So, if they share the memory location, it will return true. If they are stored in different locations, it returns false. Now, generally, I will tell you when it is stored in the same location, when it is stored in a different location, for small integers, the same location is shared. For big integers, say small integers below 256, they are saved in the same place. But when you say A is 1000, B is 1000, these two are saved in different memory locations. Same way, for floating point, different memory location. For small integers, same memory location. For big integers, different memory location. But whatever be the case, when you assign a value in a same statement like this, A is equal to B is equal to 1000, X is equal to Y is equal to 5.5. When you assign the value in the same statement, then the computer will assign it in the same memory location. This is an exception. Okay, so don't get confused with all these too much of data. So just understand the use of the operators is and is not. They are called as identity operators. They are used to find out if A and B are stored in the same memory location. If they are saved in the same memory location, it returns true. If they are stored in different locations, it returns false. Now, what is the use of is not? It is exactly the opposite of this. When you type A is not B, when they are stored in different locations, it returns true. When they are stored in same location, it returns false. This operator returns false. So this is the purpose of identity operator. Next comes the logical operators. What are logical operators? The logical operators are not, and, or. What is not and or? The logical operators operate in two different ways. The logical operators operate with relational operators. For example, it can be used to combine two conditions. Say 5 less than 10. This is one expression using a relational operator. 15 greater than 2. This is another expression with another relational operator. If you want to combine these two conditions, you can use a logical operator. What is the purpose of the word and? And means compulsory. You can remember this way. What is meant by compulsory? This should be true and this should be true. If in that case, the answer of this expression becomes true. Suppose you have 15 less than 10 and 15 greater than 2. How will you check the value of this expression? 15 less than 10 is what? False. Because 15 is not less than 10. 15 is greater than 2. This is true. Now, false and true. Because one value is false, the output of this expression becomes false. Right? So the logical operator and or not can be combined with expressions having different relational operators. You can have expressions like this: 10 greater than 2 and 5 less than 3, or 6 equal to 5, like this. You can combine the different logical operators also. Now we saw what is the purpose of and. Now let us see what is the purpose of or. The word or will tell you either this or that. Then what is the meaning? When you type the expression 5 is less than 2 or 6 is greater than 4. Now evaluate these two expressions. 5 less than 2. Is it true? No, it is false. 6 greater than 4. Is it true? Yes. Now, how does this express false or true? What is meaning of or? Either this should be true or that should be true, then the entire answer becomes true. So how will you find the answer of a given expression? See, 10 greater than 2 and 2 greater than 15. This becomes false. Why? When you use an AND operator, both the expressions must be true. But here 10 is greater than 2, this is true. 2 greater than 15, this is false. Because I'm using an AND operator here, the final answer is false. The same expression, when it is used with an OR operator, it gives the final answer as true. Why? Because one side of the expression becomes true. Only one is false. Because it is an OR condition, any one answer is accepted. Suppose both is false. Say you have 2 greater than 10 or 4 greater than 4 greater than 20. Both the expressions are false, then the output will be false. And what is the purpose of not operator? It is the opposite, the complement of a given expression. Say not of 2 greater than 10. What is the output of 2 greater than 10? 2 greater than 10 is actually false. 2 is not greater than. But when you say not of 2 greater than 10, it becomes true. Whatever is the answer of the expression, you are finding the complement, that is the opposite value. That is the purpose of not operator. Now, I told you there are two ways of using a logical operator. What are logical operators? Not, and, or. These are logical operators. You can combine the logical operators with relational operators, x greater than y and y greater than z, something like this. This is one method of doing it. This next method is 10 and 5.5. You can have literals combined with logical operators. How does it work? Before you evaluate literals with the logical operator, you have to know what are truth values. Python uses some truth values. What are truth values? Truth values are true and false. First, you understand what are the false values. Then the remaining are all true values. You can remember that way. What are false values in Python? False values in Python are 0, 0.0. The number 0 has a value false. Number 0.0 has a value false. Empty string, that is a string which does not have any element. An empty string has a value false. An empty list has false value. Empty tuple has a false value. Empty dictionary has a false value. None, the value none, nothing, has a false value. All these are all false values. Then what does it mean? Any other value except these are called true values. All the other values are true values. Only these elements are having the value false. Okay. Now, why am I telling this truth value, false value, and other things? Because you should know this to evaluate the expression 10 and 5.5. When you try to evaluate 10 and 5.5, first find out what is the truth value of 10. 10 is not 0 or empty list or empty tuple, so it has value true. 5.5 is another proper number which has truth value true. When you use the AND operator, you should remember the formula or the rule. Using AND operator, if first value is true, second value is the answer. If first value is false, first value is itself the answer. This is the rule for AND operator. You just remember the rule of AND operator. Then while evaluating an OR expression, you can just consider it as the opposite method. When you have OR operator, if the first value is true, first itself is the answer. If the first value is false, then second expression is the answer. That is the condition. It is the exactly the opposite way of our or condition. Now let us see how this works. See, 10 or 5, or let us first evaluate and 10 and 5. Now what is the rule for and operator? While using and operator, if the first operator is true, if the first operand is true, the next is the answer. So the answer is 5. Suppose you have 0 here, 10 and 5. Now what is the truth value of 0? It is false. According to the rule of and, when the first operator is false, that itself is the answer. Right? Now, I am giving an empty string and some value. Empty string, remember, is a false value, so that itself becomes the answer. Now, I give uh, 10 or 0. Why does it give 10? Because it uses an OR operator. While using OR operator, if the first value is true, that itself is the answer. Now I'm giving a false value. Say I'm giving an empty list or 5.5. Now, because the first value is false, it gives the second as the answer because I'm using OR operator. So you can also have an expression or a variable or a value here. Okay, using logical operators you have two different way of expressing. You have to know all this because you will be asked questions like evaluate the given expression. Suppose x has value 10, y has a value 0 point 0. What will be the output of the given expression? Then you should be able to evaluate the given expression, right? Next, after logical operators, we have membership operators. What are membership operators in Python? You have operators called in and not in. What is in and what is not in? If you want to check if an element is present inside another container, say for example, you have A is equal to ABCD. What is A? It is a string with ABCD. Suppose you want to find if C is present inside, then you have to check C in A. What are you trying to say here? You want to check if the alphabet C is present inside the variable A. That is the use of in operator. So this will return true. Why? Because it is present. Suppose I try to check capital C in A. This will return false. Remember, Python is case sensitive. When you try to check if a capital letter is present in this expression, it returns false because it doesn't find it inside. When you try to check not in, it gives the exact opposite answer for in. So you just know how to evaluate an in operator, then you can give the opposite value for not in operator, right? Then you have bitwise operators. What are bitwise operators? So before you started learning Python, you would have learned about Boolean operations, right? Like and, bitwise and, or, XOR, complement, and all that. When you learned digital logic, you would have learned about these bitwise operations. So when you want to operate bit by bit, say you want to say 12 and 13, bitwise operator for and is this ampersand symbol, bitwise for or is this symbol, this pipe, for XOR it is carry, and complement it is tilde symbol, this symbol. So when you find the complement of 5, which means Python will convert this 5 into binary and give the complement of it, right? Next, we will move on to associativity or the precedence of operators. What do you mean by precedence of operators? When there is an expression, which is the order in which it has to be performed. For example, you have an expression like this. Suppose you have an expression like this. Which is the order of evaluating this expression? For that, you have to know the order of the precedence of operators. Whenever you are given an expression like this, you have to evaluate the brackets first. Like how you have the board mass rule in math, the same way, first the brackets has to be executed. So, which is the expression in the bracket? 4 minus 6. So, the answer of this is minus 2. You have to evaluate this one first. Then comes the arithmetic operators. Among arithmetic operators, the first preference is given for these four operators: star, slash, floor division, and modulus. Multiplication, division, floor division, modulus. Among these, all have equal precedence. Then, which is the order of execution? It comes from left to right. Say, for example, because I have written multiplication operator first, it doesn't mean this has greater precedence than double slash. It is not that way. Suppose you have an expression like this, multiplied by 2 modulus 2, like this. All these three have the same precedence, so you just have to execute it from left to right direction. All four have the same precedence, right? Okay, so in this expression, in that way, you have to execute. Before this, you have the exponent. Next, you have the exponents in the order. Among arithmetic operators, first comes the exponent operator. So you have to execute this one next. So 2 power 2 is 4. Now what is the expression looking like? 10 into 4 minus 2 into 2. This is the left out expression. After this comes multiplication, division, floor division, and modulus operator. These four have the same precedence. For example, if you have 10 double slash 3 modulus 2 into 5, it doesn't mean you have to execute this first and this next. It just comes from left to right. Whatever operator comes first, you can execute that. So this will be performed first, then this answer with this, and this answer with this. It goes on like this. Okay, so all the four operators have equal precedence. Then comes the addition and subtraction operator. So with this, we have the arithmetic operators get over. Then comes the relational operator. If you have any less than or equal to, greater than or equal to, something like this, then you will have to execute this next. After completing the arithmetic operators, you have to execute the relational operator. Then comes the logical operator. All relational operators have the same precedence, but among logical operators, first comes the not operator, then comes and, then comes or. So if you have an expression like this, not true and false or true, then first you have to find out what is not of true. It is false. And false or true. What comes next? And operator. So false and false is false, or true is true. This is how it goes. So first you have to execute the not operator, then the and operator, then the or operator. Even if you have true or false and true, not false, something like this, then not first, then and, then or. It goes like this. So this is the order of precedence. So again, I repeat, when you have an expression to be executed, you have to do the brackets first, then exponents, then multiplication, division, floor division, modulus, from left to right. Any order is okay. Then comes addition and subtraction. Then comes our relational operators. Then comes not, then and then finally or. Right? So this is the order of precedence. Hope you understood all these concepts. In the next video, you will learn about how to get input from the user, print the output, and write simple programs in Python. Thank you.